right, well, we're going to continue on our chapter 10, information on the difference of proportions, and now we're going to focus on confidence intervals. If you watched my other video on sampling distributions for a difference in proportions, then you might have seen this little slide, these notes prior. But now we're actually going to go into confidence intervals for the difference in proportions. So what we have right here is a two sample. We've been dealing with a lot of one sample in the previous chapter. And now we were talking about two sample Z interval for P1 minus P2. All right, proportion 1 minus proportion 2. Now, the thing is that when you're writing this out, our parameter, all right, our parameter is going to be stated as the difference of, well, P1 minus P2, and that's going to be the true difference in the proportions of whatever the context we're talking about here. Okay, to find our statistics, we take the statistic of P1 minus P2, and so from there, that's going to give us our statistic that we're going to use and our point estimate, and then we're going to go plus or minus our critical value, followed by our standard error. And our standard error is the standard deviation, which we learned about in the past chapter when we're taking the difference in proportions. We just take the variance of each one of these as well. Now, going through here, we're going to do some interpreting of these intervals, and what this kind of makes sense because we can make some inferencing from this interval is that if we notice that we have two positive values, well, the only way you can get two positive values if P1 is greater, because obviously when you take the difference in these, if P1 is greater, they're always going to remain positive. So if P1 is greater, we're going to have this interval, both are going to be positive. If you notice that both ends of the interval are negative, then we know that P2 is going to be greater because obviously P2 has a negative value, which will make the two values on the interval negative. Now, if we have a negative then positive, what we know is that we really don't know anything. We don't know which one is greater, so it's inconclusive. Maybe there's no difference, but on this interval we're just not sure. Okay, so that we wouldn't have any evidence and convincing evidence to state whether P1 or P2 would be greater than this. So let's try an example of this. A Pew Research Center poll asked independent random samples of working men and women how much they would value job security. Of the 106 women, 79 said job security was very extremely important to them. So I'm going to say that is our P1, or actually our one, and that's going to equal 709 over 806. All right, and so that's going to be women. I'll just put a W there. All right, for women. And then we have compared to 802 of the 944 men surveyed. And so we have this other one with men, and that's going to be 802 divided by 944. Okay, so construct and interpret a 95 constant interval for the difference in proportions of all working men and women who consider job security very or extremely important. Okay, so first thing we want to state our parameter, P W, all right, minus PM, all right, is the, all right, true difference. All right, difference in proportions, all right, between women and men, men in their response to job security, or response to the importance of job security. Okay, so we got that. All right, so now once we state our parameter, the next thing is we want to go figure out what our values are going to be. So if we take this right here, we're going to figure out what this, we're going to take P1 for our point estimate. We're going to take this right here and minus that from P of M. And so I'm going to find out what those two values are. So if I take 709 and you divide it by 0.806, you should get a value of approximately, all right, 0.879. And I'm going to just round that to 8 because we have that. So we're going to have 0.88. And then we're going to figure out the same thing over here. We're going to take 802 divided by 944. Okay. And then what we have right here is going to be, all right, 0.849. Okay. Actually, that's going to be 0.85. All right. And we have that as well. Okay. Like so. All right. Now, from here, when we're doing this, is that in order to make sure that we are using a proper critical value and we have all our independence, we're going to add that to our critical value z, okay? And we're going to take our standard deviation of this. And now we're going to have a 95% confidence interval. So because we have a 95% confidence interval, we're going to stay at 1.96 is going to be our critical value, and we're going to put that in there. From here, okay, we're now going to figure out what our variances for each one are. So we're going to have 0.88 times 0.12, all right, over 806. And we're going to add that to, all right, our other one, which is 0.85, all right, times 0.15. And that's going to be divided by 944, okay? And that's really going to give us our value there. Now, one thing that we probably want to make sure that we have, all right, and when we're doing any type of confidence interval is that we want to make sure that we have the correct conditions for this. And we didn't start doing that. So really right here is I want to state this. So I want to state my parameter. I forgot to plan. Okay. And so what we're doing here is we're going to plan what we're going to do. And actually we're doing a 2 sample. All right. Z interval for P1 minus P2, all right, or the difference in proportions, okay? So you can also say the difference in proportions here, proportions, when we're doing that. Now, in order to do this, we have to make sure that we have a random, all right, random samples, and each one was 2 random samples, and we had that, okay, so 2 random samples. We also want to check for independence, all right, for each one of these. And so if we said this right here, and we want to take men and women surveyed, and so is the women, all right, if we just say a woman, and we said that, okay, they took 806, is that going to be less than 10% of all women? I think that would be true, at least working women, all right. And when we have men, all right, we want to test out that one as well. So we have 944, and it's going to be greater than 10% of all working men. All right, and I believe that's probably a fair assumption for that. And then finally, the third thing is we do, because we're using a z, all right, a z interval, we want to make sure this is normal. And when we're doing with the normal, okay, is that since we're testing this, we want to just make sure that our p-value, so in this case we have 0.88, all right, and we multiply that by 806, all right, is that going to be greater than or equal to 10? And along with 0.12 times 806, that 2 is greater than or equal to 10. We want to test that because that's for women, and we also want to test that for men. And so if we take 0.85 and multiply that by, all right, 944, is that greater than or equal to 10? Which it is. And we're going to take 115.15, 944, and is that greater than or equal to 10? Which we also know it is. So both of them are normal. So once we have our plan, we do want to go continue the 4-step process. And now we're going to look at our do. All right. And this is our do right here. And we were just going through our do. And so what we want to do is figure out what these final values are. So if we took this and find our standard deviation, all right, and we had the square root of 0.88 times 0.12 divided by 806, and then we're going to add that to 0.85 times 0.15 divided by 944. And we should have a standard deviation of this. So in the same way, we can take 0.88 minus 0.85. And what we have is, all right, continuing on, 0.03 plus or minus 1.96 times our standard error, which appears to be 0.0163. And I'll just go over 163 like so, okay? From here, we're going to add and subtract that. So if we take our standard error of 0.0163 and multiply that by 1.96, which would be 95%, so we have 0.0319 plus and minus 0.03. All right, and we'll take that and add it to 0.03. And we should have a upper end of 0.062. We'll say that. All right, and then we'll go on the bottom end. All right, 0.03 minus 0.0319, and then we have a lower end of negative 0.0019. Okay, and so that appears to be our confidence interval. Now, we can also check this on our TI calculator. So if we go over here in stat and we go to test, and you go down to the bottom, you'll see that we have a 2 prop z interval. So that's a 2 proportions, all right, a 2 sample, all right, z interval for proportions. I'm going to put that in there, okay? And now from here, you can see that I entered all our values. So x means what is the total amount that we have for, I'm just going to say for women, all right? And that's going to be out of 806. We have our x2, which is 802 out of 244. We have our confidence level, which is 0.95, and what we're going to do is we're going to calculate that. All right, so I keep on going down and I press enter right here. Okay, and you realize that we have this as our confidence interval. I'm going to take this and just put it right here. All right, and so you see that yes, of all these different things, we get the same confidence interval that we had, or that we found right here, negative 0.0019, 0.062, and we found that, yes, this matches it up. So the final part of this is we're going to finish up our conclusion. What do we conclude? Well, we are, all right, 95% confident, all right, that the true difference in proportions of women and men, job satisfaction is on the interval. And what is that interval going to be? That interval is going to be from negative 0.0019 to 0.062. And that's what we have. All right, and that's our final part of our 4-step process, which is conclude. So it's very, very similar to when you have a 1 sample, but now we're just adding the 2 sample and going through and doing this. All right, so key things are when you're doing this is that you want to make sure that when you're doing a 2 sample z interval for proportions, remember state your parameter, go through your conditions, and then make sure you do your do process, and then you can conclude what you have there. Okay, well, I hope this helps you out, and good luck, God bless in the rest of the problems.